Hello, and welcome back to the course Network Analysis with Python. Today, we will be exploring how attributes behave in Networkx. In the previous lecture, we have already encountered how to code attributes in various kinds of graphs and in networks. So now, let us start with the edge attributes. Now, in any graph, each and every edge, which basically provides us with the relationship between various nodes, has some attribute, whether it be a weight or kind of relationship. For example, here is an example of a network where in an office there are some peoples who have collaborated on different projects. Now, this is a very small office, so we will assume that in a small town, we will assume that the office is in a small town, so many people know other people very well. So they could be family, they could be friends or neighbors. So it's a household office. So in such a network, in networks of such offices, the edge weight as well as the relationship between these edges, different edges, matters a lot. So these relationship can be graded as, for example, whether a worker A and B are related by blood, that is their family, or they are mutual friends, or they can be a co-worker. Now, depending on how much good their relationship is, how much the weightage of the relationship is, the network can take turns. For example, A and B has a good relationship, but not so much good as C and B. So here C and B has a weight of 13, whereas in case of A and B there is only a weight of 6. So now how do we write these edges? We basically add edge, and using dictionary in Python, we use weight. We assign each and every values for weights, and strings, for example, family, friend, or any other relationship status in case of relationship. Now, in order to access these values of edges, we just use the function edges, g.edges. So here that will provide us with the list of all edges. And the data, the edge points, each and every, in order to get all the values of the edge, we just have to use the same function with a value of boolean value of true in case of data. And if we want to only get a certain kind of attribute, for example, we want to get the attribute of weight or a relationship, we need to specify within the function of edges which attribute do we want to print. For example, here in case we want to print the list of all relationship, we just input the data is equal to relation. Now, if you want to print the weight values or the strength of the relationship, so we just type data is equal to weight. Now, in order to access very specific edge, now what we do, we use the dictionary condition g.edge of A and B. So that will give us the output or the attributes of the edge AB. That is, A to B has a relationship of family as well as a weight of 6. Now that is our output. That will be given if we want to access a single edge. Now that edge is basically the dictionary type value. See, relationship is corresponding with family, and weight is the corresponding with its value 6. So that is why it's a Python dictionary. Now within that edge, within that particular accessed edge, if we want to print only the value of weight, so we will just specify the condition weight. And in case of only this, if we want to only print out the value of relationship or the relationship status, we just have to specify the connection relationship, and it will provide us with the output relation. Now, in case of directed or weighted networks, most digraphs are generally have weights in them because they represent from which direction the workflow is going, or from which direction the interest, the mutual relationship is shared. So here assume such a network where A and B corresponds, but at the same time A corresponds with B. It's not that B corresponds with A. So here the order really matters, because if that means A and B, edge AB is not same as the edge B and C, B and A. So they are completely different because they have completely different sense. So here we just declared the directed or weighted network nx.digraph, as we have already discussed in the previous lecture, and we input in the similar way we input the attributes weight and relationship. Now, while accessing the attributes, we have to keep in mind that the order of the edge matters, otherwise it will be an error. So g.edge cb, if we want to print out weight, we get 13. If we want to print out relationship status, then we get friend. So here B and C and B and B and C are completely different. So it's a very important point that we have to keep in mind. Now, in case of multigraphs, which are quite which are used frequently, for example, A and B has a family relationship, but they can also be friend. So in such kind of networks, we just use the graph function multigraph to create such network, and then use this, and in the similar way we just add the attributes to weight and relationship. Now here in case of an undirected multigraph, we really don't have to concern ourselves with the order. So we just simply write AB and from which data point we want to print, so that data point will get printed out. It's a very similar manner, just like the normal graph for undirected normal graphs, the same as a multigraph. The multigraphs only differs because of either their relationship status or because of their weight. Now both can alter, but generally multigraphs are designed in order to specify certain relationship status weights, but if weight is allotted, then it could be different, it could be same. Okay, now let us look at some directed multigraphs. These are very useful in certain scenarios. So directed multigraphs are basically same. You can use just multigraph function to create a directed multigraph, or we can also use the function multi-digraph. It's a new function, so it recently came up with the update of Networkx library. So multi-digraph can also be used to create a directed multigraph. But if we don't want to use a new function called multi-digraph, or if you are using an old version of Networkx, well, we generally do not, but if someone wants to access an old version of Networkx, we can use multigraph. And in order to create the directed multigraph, we just simply add the status of the weight from A to B and B to A, or the direction from which, here the order matters, so the direction from which we want to create an edge, so B to A or A to B, and then use separate weights or separate relationship status to identify or distinguish between two edges among same nodes. Now accessing these edge attributes are pretty similar. They are not very different from the other specification of attributes or accessing of attributes we have seen so far. So like the directed graph, here if we want to print A to B or B to A, here again the direction matters. If the order is slightly different, then the whole then it will create a lot of error. So edge attributes, so here that is up with here. Now let us explore some of the node attributes. Now, like edges have attributes, the nodes or the elements or the people could be different. See, in an in a office there can be people with different roles. For example, one person could be a manager, to another person can be a clerk. So different, not only they have a certain kind of relationship, but also they are part of a system which allows them to take various roles for distributing jobs, for performing various different jobs. So here, creating node attributes, we use the same way nx.graph to create weights. Now adding node, we just use the add node function to add nodes. We use specified. Generally we do not need to separately create nodes. If we just simply write g.add edge, it automatically creates a node for us. But when we want to specify certain attributes, for example node position, now that is generally used for visualization purposes, but we will see the use of pause function, that not function, pause label, for adding in case of adding nodes. We will see that while we were working on the visualization, but now we are concerned about the role of the node, or of the flavor or the nature of the node. So for that, A here is a trader and B is another trader. They could be an analyst or a manager. So they are depending upon the post of these people, they have different roles. So we just use an attribute role to classify these nodes. It's very similar to adding edges, just the same function, just a variation. Now accessing them is very similar. While we were using g.edges to access the edge data, we just use g.node to access the edge node data. Now if we want to print out the entire data, we just use the data equal to true. That gives us the list of all nodes along with their attributes. Now okay, for summarizing purposes, let us summarize what we have studied so far, what we have come across so far. We now know how to create an edge. We know how to create a node, though we don't really need to create a node. But if we want to classify these nodes, we would have to create a node and add attributes to these nodes, so that we can classify them according to their nature or according to their flavor. So accessing them is pretty simple. Accessing nodes or edges are very similar in nature. Now in case of directed graphs, accessing edge matters, not in case of node. Now accessing edge attributes, like we have already discussed, if we want to print the entire data, we just use the Boolean expression true, and for selected attributes we just specify what kind of attribute we want to print. And if we want to access only the weight, or access a single attribute of a single edge, then we have to first access the dictionary of the edge, and then we have to specify which attribute we want to print. Otherwise, if we just use g.edge AB, with that will print out the entire dictionary of all the entire dictionary of values, entire dictionary of the attributes of that edge in particular. So thank you. Let us continue our